the present, be it brain cancer, breast cancer, colon cancer.
Are these normally at advanced stages where the risks are less relevant to the...
At the present time, yes. There's a probably the most successful gene therapy at present, aside from some rare genetic diseases, is for heart disease, where a physician in Boston, Jeff Eisner, has succeeded in injecting a gene, a normal gene for a factor that causes the growth of blood vessels, directly into the hearts of patients who are basically bedridden, and have a number of patients now who are back leading a perfectly normal life.
Alan, do you see these kinds of procedures really helping with diseases of the brain?
Well, I think one important point that addresses what Shep said is that these are procedures that are medical procedures that modify existing cells. So when French talks about putting in DNA that will stimulate the growth of the growth of blood vessels into a diseased heart, or I might think of supplementing the ability of cells in an epileptic patient to quiet neural activity. Those are all procedures that are not so different from other medical and surgical procedures. They're not going to have any impact on evolution. They're not going to be revolutionary in the sense that Shep worries about.
What is, if somebody can define for me, the Human Genome Project, because that is one of these big science projects that is now hot in the news, that is really lying at the basis of this?
That's the attempt to determine the sequence of all 3 billion nucleotides, which are the building blocks of DNA. There are 3, we each carry around with us 2 copies of a set of instructions in DNA, and each of those sets of instructions is 3 billion nucleotides long.
And it's about 100,000 genes.
And of those 3 billion nucleotides, about 5% of those 3 billion actually code for the proteins, which are the business end of a cell, and there are about 100,000 of those. We think 80 to 100,000.
Greg, what is human germline engineering, and how does this take it to a more fundamental level?
Well, first of all, back to the Human Genome Project, I think that what's important there is not just that sequence, understanding the sequence of the human genome, but understanding all of the variants that exist, all of the polymorphisms, coupling that with genomics,
being?
Different variants of different genes. So what makes you different from me, for instance.
Right.
And being able to identify which clusters of those are associated with various human traits through genomics, which is the use of computers to analyze all of this complex data, and then coupling that with new technologies like DNA chip technology, which is using an actual, like a little chip, like a computer chip, that can essentially identify various polymorphisms on maybe 100,000 genes. Eventually they'll be able to do that.
Different ways that genes can be expressed.
So essentially we'd be able to get a genetic profile of an individual very cheaply and very quickly. Now when you start getting that kind of information, then it becomes feasible to imagine the alteration of genes at a more fundamental level in the first cell of the embryo, for instance, which is what germline engineering is. That comes from the germinal cell, like a seed, germination. And the difference between that and the kind of somatic engineering that French is doing now is that genetic engineering is really just a therapy, like another medical procedure, in which it is an intervention into the existing cells of the adult. If you go back and alter the genes in the first cell, in the first embryonic cell, then you're changing all the genes in the body, and you're making very profound changes that are essentially the beginnings of human design. And that is the kind of thing that could have the enormous impacts that we were discussing here.
Doesn't this have a bigger impact than 1%? Well, this guy's scaring me.
Oh, I am worried, yeah.
So I'm sitting on this side of the table.
I am much more worried right now than I was when we started the program listening to Greg, because I can see gene therapy. I see curing diseases, not only curing the disease itself somatically, but even correcting the genes so that the progeny, the children of these people who have been cured don't carry the disease. But designing human beings, where do we have the wisdom for that? The effort to design new human beings in my book is as destructive of what we are as atomic bombs potentially are.
right.
We have stopped atomic
The
bombs.
problem with
from
atomic
exploding.
bombs, you need a big infrastructure to do that. With designing
But there's a
genetic
major
therapy,
difference.
you can do it in a laboratory, like
no,
you can make bootleg liquor.
No,
correct?
you can.
There's a major difference between using the idea of atomic weapons and comparing that to genetic engineering. Because the one thing about issues like cloning, about genetic engineering, is that they, as long as the decisions are made on an individual basis by the individual who is being treated or by parents that are trying to do the best for their children, then innocent individuals who are not participating in this are not at risk in the same way as with atomic weapons. An accident by some madman can literally destroy vast numbers of human beings. The only way that germline genetic engineering, or genetic engineering for that matter, can be used broadly enough to have any impact at all is if it is wholeheartedly embraced by vast numbers of people, because they see it in their benefit.
So you're assuming a non-totalitarian society in everything that you've said. You're talking about free choice as if that's a given.
Well,
But that's not necessarily the history of this century.
Yes, but with any technology, it can be completely perverted by a totalitarian regime. But totalitarian regimes have at their disposal all sorts of low-tech technologies to do anything, to do great evils. If you look at what Hitler did with eugenics, the real evils that he did were done with other technologies, with low
Francesco?
I
technologies.
regret to say that the proposals that you are making, for me, sound like potential for very great evil. Because if we try to produce, to design new human beings, first of all, who makes the choices as to what we are going to select for? I mean, do we get taller people or more people with blue eyes? Or better, at least those are the ones who make the most money.
Ambidextrous can go pitch with your left or right hand.
Some people, when I raise these questions, tell me that you would agree that what we may want is to have people who are more intelligent. Well, I'm not sure of that. I am not sure what problems that mankind faces today will be solved by having more intelligent people. I'd rather have people who are morally more responsible or more sensitive to art and
That's a harder
aesthetics.
gene to find.
But what is the free choice? Who will have this enhancement? Think about the differences in availability we already have with medical care in this world. When we start having enhancement possibilities, how that will magnify the problems for us.
Well, I have to say that I as much as I think that genomics and gene therapy and even germline manipulation is interesting and important to discuss, I think some of the qualities that we're talking about are unlikely to result from genes. I think it's curious that the society has embraced the idea that issues such as mysticism or morality or ambidextrousness are going to turn out to be genetic rather than cultural. And it sounds an awful lot to me to hear lots of professors talking about how their cleverness is genetically determined. Nobody on this panel, of course. But to hear them, it reminds me of Max Weber's argument about Calvinism, that somehow by proving that we have good genes, we are proving that we are among the elect, and somehow that justifies whatever else we want to do.
I don't think anybody's saying that genetics totally controls morality or mysticism or some of these qualities, but I think it could give a predisposition for that, and you could have a bell curve skew. So I think that the danger is a real one.
Alan has... okay.
French, does this discussion concern you? I mean, you're in the lab. We're on the we're in the balcony kibitzing and commenting and complaining, and you're there helping people.
Well, these are the issues that I first started to raise about 30 years ago. And it's considered to be very weird for bringing up something that's sort of like being worried about property values on Mars. It's sort of why worry about something like this? But our ability to do not gene therapy, which is good, but gene manipulation, which is really what we're talking about.
Very close, very close, very similar.
To do gene manipulation is such that even though really nothing is going to be possible in the way of changing human beings in the next 10, 15, 20 years, 50 years from now is quite another matter. And my feeling very strongly is the only way to prevent the misuse of this technology is public education, an aroused public that understands the potential problems and basically does not allow the subtle